Hello, welcome back, Math 30-2. Today we are looking at evaluating logarithms. Okay, so let's take a look at our first example here. It is just solving. So evaluating means just solve for the logarithm. This is saying 3 to the power of something is equal to 81. So 3 to the x is equal to 81. Well, what is the value of that x there? It is, if we change this to base 4, we get 3 to the 4. So x is equal to 4, so we have 4. Next one here is 4 to the power of what is equal to 64? 4 to the power of something is equal to 64. So that's going to be 4 to the power of x is equal to 64. I put that, that's 4 to the x is equal to 4 to the 4. So x is equal to 4. So we get 4. Next one's pretty simple. It's saying 7 to the power of what is equal to 7? Anything to the power of 1 is equal to itself. So 7 to the power of what is equal to itself? This one's 1. This is saying 12 to the power of what is equal to 1? Well, what to the power of anything is equal to 1? 0. So this one here is 0. 12 to the power of 0 is equal to 1. Okay? So now let's take a look at this question here. We're just generalizing the last two questions. It says log b. So b to the power of what is equal to 1? So b to the power, any number to the power of what is equal to 1? That is 0. So we have b to the power of 0 is equal to 1. So then our answer is 0. Okay? The next one here is saying b to the power of what is equal to b? Well, it's going to be 1. Okay? B to the 1 is equal to b to the 1. So this one's 1. So anything where we have a log, where the base is equal to itself, that's 1. Here, if it's log 1, our answer is 0. Okay? That's a key thing to remember. So now we're evaluating some a little bit more tricky ones, as we have some fractions and square roots in there. But it's not that difficult. This too makes it look complicated, so we're going to ignore it to the end. First, we're going to look at the more complicated part, which is this here. So that's like saying 8 to the power of what is equal to 512? Oops, 512. Well, 8 to the power of 3 is equal to 512, right? So this is actually equal to 3. So we have 2 multiplied by 3 for our answer, which is 6. Okay? Our next part here is looking at it. It says 2 to the power of what is equal to 1 over 32. 2 to the power of what is equal to 1 over 32. Well, this is a fraction, so we know it's going to be negative. I know 2 to the power of 5 is equal to 32, so then 2 to the power of negative 5 must be equal to 1 over 32. So we get negative 5 for my answer. All right? Here's this one here looks complicated because there's a square root in there. It's not that bad. This is just saying 5 to the power of something is equal to the square root of 125. Or 5 to the power of x is equal to this 125 to the 1 over 2. But this is the same thing as 5 to the 3. So then my x is 3 over 2. Okay? So this is kind of just a review of the lesson before. Nothing overly that new. It's just there's no equal sign there. It just says evaluate. So let's try this one here. It says log 1/3 is equal to 27. I'm going to zoom in because it's pretty small so we can see it. So we have log to the 1/3 is equal to 27. Okay? Well, this is a fraction that's not. So as soon as we have that, we know it's going to be a negative. Well, 3 to the power of what is equal to 27? 3 to the power of 3 is equal to 27. So our answer would be 3 if neither of them are fractions, but one's a fraction. So it's going to be negative 3 for my answer. Okay? Let's take a look at this one. This looks very, very confusing, doesn't it? Like we have this exponent here. Oh, that's a nightmare. Well, then let's just do the tricky part first, that log. So 4 to the power of what is equal to 16? 4 to the power of 2. Okay? So this part here, this whole log is equal to 2. So it's 4 squared, which is equal to 16. That's it. That wasn't that bad. Well, let's look at C. we have this subtraction here that makes it look messy, not so nice. It's not really that bad when you look at it. 1/2 to the power of what is equal to 8? Well, let's look at this. It's 1 over 2. 2 to the what is equal to 8? 2 to the 3. So then 1/2 to the 3 should be 1 over 8. So we have 3. And we're subtracting. 2 to the power of 3 we said is 8. Well, this here is 1/2. So I want to put it, it's going to be negative. So this should be negative. To flip this, so it's 1 over 8. So then this is going to be negative 3. Okay? So 3 subtract negative 3 is 6. That's how we get that one. This one's 16 now. All right. So here we're going to look at just the natural log of it and how to convert it on a calculator. So first we're going to evaluate log 1,000. Now if you remember, there's always a 10 there. So saying log base 10 is equal to 1,000. So that's 10 to the x is equal to 1,000. Okay? So what is x? That is 10 to the x is equal to 10 to the 3. So x is equal to 3. That's my answer for that one. Now let's take a look at B. It says using the log key on the calculator. So it has to be faster, right? So I'm going to say log, 10,000. Bracket. It's 3. Hey, it's the same answer. Isn't that so fast? But it only works when it's base 10. Because our calculator is in base 10. We'll find out later in this lesson how to change the bases. Now it says evaluate the following logarithms to one decimal place where necessary. And we're using the natural logs. Well, natural log is just if your base is e. So that's all that that's saying. So in our calculator, we are just going to put natural log of, what does it want? 5, which is 1.6. Okay? 1.6. Now this next one, this is the same thing as saying, which is also 1.6, because that's the same as that. Because we're in base e, and that's what the natural log means. And our last one here, this is the same thing as saying log e to the e. Well, what's anything to the power of what? It's 1. Okay? What e to the power of what is equal to e? Okay? That's a natural number. All right. So right here, this part here is going to explain how to do your change of base. So this is a quick review of the change of base. Okay? So how to type in if it's log 5 in the calculator. We did a little bit of this in the unit before. We're going to go over it a little bit more in our next few examples. So here's our first examples for typing in the calculator change of base. So this is saying log 4, 1024. Okay? So we're going to first put my x value from this formula right here that I suggest you memorize on top. So it's log 1024 all over log 4. And we punch that into the calculator. Now I suggest putting this all in one line just like how I did there, which gives us 5. Okay? This one right here, I'm going to multiply it by 3 later. I'm going to first do my log and then multiply by 3. So it's log 1 over 1,000 all over log 2. And then we multiply by 3 at the end. And we have log 2. Okay? That gives us that, and we times that by 3. I'm going to get negative 29.90, because this is 2 nearest 100. Okay? This one here is interesting. So once again, we're given an exponent in the logs, so I'm going to simplify the exponent first. So that's going to be 6 to the power of log 216 all over log 6. So let's put that in. Log 216 divided by log 6. I end up getting 3. So that's 6 to the 3, which is actually equal to 216. Okay? Now the last one looks very confusing, doesn't it? But it's not that bad. This is just going to be log Square root 1 over 1024 all over log 2. So let's plug that in. We just have log, we have the square root of bracket 1 divided by 1024. And this is all divided by, I better close my bracket. It's all divided by log 2. And I get negative 5. Okay? All right. Now here we go. It says, explain how using graphing calculator to produce the following function. So in this one right here, if we look at this, we have to change a base to put in my graphing calculator. Y is equal to, we're going to say log x divided by log 7. Looks like that. So let's put that in my calculator. And I already have it here. Log x divided by log 7. Now, we're going to sketch this. Always they intersect at what? 1. Okay? And when x is 7, y is going to be 1. Okay, so I'm going to say when x is 7, y is going to be 1. That's something we learned from before. Now, it says use the calculator to solve the following. We want to know when it's equal to 5. So to help me out with that, I know 7 to the power of 5. Because that's what it's saying. 7 to the power of 5 is equal to x. So that's 1607. But we want to graph that. So that's going to help me. I already put that in there with my window. And 1607, I'm going to put my x max at 20,000. Okay? My x min is 0, my y max is 10, so I could try and see it somewhere in there. And I look, I get an intersection somewhere there, so you're just going to calculate your intercept. First curve, get close as we can. And when y is 5, we're almost at 5. I'm very close. There we go. Enter, enter, enter. I get 1607. We found an easier way. We could just convert, but here's. Now the next one is saying when we have an equation like that. So I'm going to solve for this and isolate for the log 7x. So in my calculator, this is still the same as 9 is equal to 3 log 7x. So then divide both by 3. I just move that 9 to that side. I'm going to get 3 is equal to log 7x. So we have to put now, I'm going to delete this. Oops. Push the button, delete. I'm going to put a 3 there. And we're going to graph and find the intersection for when it's equal to 3. And it's way over there. So I'm going to change my window. I'm going to just put maybe 2,000. So 20,000. Maybe that wasn't high enough. Yep. And now we're going to calculate my intersect. So I'm going to go when y is equal closest for y is equal to 3, which is right there, and just guess. Oh, we get 343. So it's equal to 343. Okay? Now it says solve the equation by converting to exponential form. Well, that's pretty simple, this one. This is saying 7 to the 5 is equal to 1. Oh, that should be 18607, I believe it was. 16807. 68. I copied the numbers. 6807. And this one right here is going to be 7 to the power of 3 is equal to x, which is equal to 343. Okay? So that's everything. Good luck on your quiz tomorrow. Or, sorry, good luck, and I'll help you with your questions tomorrow.